Okay, hello everyone, and I'm happy to see you and to welcome you here at DotNext at the talk Building and Generating a .NET Client for a Large API by Maarten Balliauw. Maarten is a developer advocate at JetBrains, and his main interests are in ASP.NET MVC, C#, Azure, and PHP and application performance. Well, I'm actually a little bit surprised to see PHP in this list, but let it be so. And also we have Maxim Marshinov, our expert in this session, co-founder of Hita Group, outsource company from Kazan, and he also, except working in Hita Group, he also teacher in Kazan State University. Hey Maxim, hey Maarten, how's it going?
Hi, hello.
Maarten, the first question, I guess I would even start with Maxim. So Maxim, the first question is, have you ever used JetBrains Space as a tool? As far as I understand, it's public. It will go public like in a week or so. So have you seen the tool itself, Max?
Yeah, there are three reasons why I volunteered to be an expert here. Reason number one, I lived in Antwerp for quite some time, and that's a beautiful city. Number two, Maarten, once again, I'm really want to say you thank you for your support at NDC. We all know how difficult online conferences are for both speakers and the audience. And number three, I actually used JetBrains Space quite some time ago. And I'm really interested and eager to know the state of the art as of now, because for us, it might be another software that we would like to use as a company. So
cool.
why wouldn't you? Yeah. Why wouldn't you briefly describe the system to our audience to let them better understand what the technical challenges are to build such a system?
Yeah, perfect. Yeah, I'll go a little bit deeper into this during the talk as well. But the general idea of Space is that it's an integrated team environment. I know JetBrains is known for having integrated development environments where you have an IDE, where you do coding, where you get code analysis and things like that. And in Space, we try to do the same thing for your team, where we combine technical things around your team together with things like going on absences, communication, issue tracking, and all of that in one tool, so you don't have to use other tools or have to combine and integrate other tools together to do what you want to achieve.
Oh, okay. Thank you, Maarten. And I guess we can just dive into the talk right now. Let's start, everyone. Good luck.
All right. Thanks. Yeah, welcome from my side, everyone, as well. Welcome to this talk, Building a Friendly .NET SDK to Connect to Space. Before we begin, I want to quickly go over the agenda because it would be impossible to show you all of the stuff that we did around code generation for our HTTP API without covering what JetBrains Space actually is. I will not make it a commercial talk and so on. I will just highlight a couple of things that we'll see later on during this talk as well. I will then look at the HTTP API that we have, see that it's actually a really big one and that it's almost impossible to manually write code for that and to create a nice SDK for it, which is why we started doing code generation. I'll talk a little bit more about that and then also focus on how you can increase developer experience when we start building an SDK like the one that we have for Space. So let's start with JetBrains Space as a whole. And I'm not going to do any slides on this. I'm just going to do a very, very quick demo of what it is. So if you open Space, you will see something like this, which is the home page where you see your agenda for today, your favorite projects that you are working on, the teams that you are in, etc. And you can already see that this tool integrates the agenda with projects, with repositories that are in there. So you see the Ktor and Ktor samples repository that is in there. So we combine those technical things with some more people-oriented things like teams, like vacation tracking, like the fact that there is the agenda and so on in there as well. Another thing that we have is it's very often difficult to communicate with a lot of people in the company. So we have blog posts in there that you can post internally to either all of your users of Space in your organization, to a certain department or a certain team in your company or to a certain location. And at JetBrains, we actually use space internally as well. And for example, if someone has a birthday in our Munich office, they would do a post in the blog and target it to just the Munich office, and people in the Munich office will know about this fact without bothering all of the other offices that we have. And me being a remote worker, I never get to join birthday parties like this and never eat cake, but that's the way it is. But I'm also not bothered by those blog posts that are appearing there. In projects, you will see that you have a project. For every project, you can have code reviews for all of the repos that are in there. There's checklists, there's issue tracking. For every issue, you can look at what is there. Issues can have a status, who is assigned to it. If there is someone in there, you can start commenting on the issue in here. Let's say comment goes here. And then everyone who is already subscribed to this issue, which are all of the previous commenters, will see this pop up in chats, which is another thing that is in space. So there's an integrated chat where you can have chat rooms, talk with people, talk about issues. You can also see the events that are happening, subscribe to the events, and so on. For every single message that is there, you can create a to-do item. So if there's something that you have to follow up on, just click the button, and all of a sudden you will see that this item is now all of a sudden in your to-do lists. And you can complete that. You can postpone it until tomorrow, for example, if you want to do it, or create an issue for it if it's something that you actually have to work on. What else is there? There are documents, so you can have your own personal documents where you can do something like Google Docs where you can collaborate on text documents. You can publish them as blog posts. You can have knowledge bases. So it's a lot of things that are actually in one product and that are all integrated in this one thing. Now, why did I want to show you this? Because there's a couple of considerations to make if you start looking at the actual API that we have for Space. And let's talk about that now. So in the Space API, if you think about Space and the whirlwind 2-minute tour that I gave you through Space, you'll see that this integrated team environment has lots of opportunities to store information. So you could just store your Git repositories in Space, but you could also have issue tracking, automation, and build servers in there. So all of that is all part of Space. And the more information you have in Space, the more value you get from Space. There's a lot of internal integrations by default. So for example, we do vacation tracking in Space, which means if you open up a code review, you will immediately see that your colleague is, for example, out of office for the next 2 weeks. So you may want to focus on someone else who is in the office to do that code review. The blog post targeting is there. If you do calendar integration, you can write a blog post and attach an event to that. It's really integrating a lot of things out of the box for you, and all of those things are there. Everything can be a to-do item, for example, as well. So that's all really nice. The only thing is we have no idea what integrations you may want to build. What extensibility do you need as a user of Space? What external systems are you using, and do you want to use to pump information into Space or extract information out of Space? We don't really have a good idea. You may want to import data from other issue trackers or post messages to chat, for example, when you do a deployment to your Azure or AWS clouds. Maybe you want to do external user management while still making use of different user profiles and so on in Space. Maybe you want to synchronize locations with other information that you have in Office 365, things like that. Maybe you just want to use the API to extract data that is there and build dashboards about how many people are using source code or how many issues are being created every single week and so on. So we have no idea what exact integrations you need. We have a good idea of what we can provide out of the box, but there's always going to be cases where you want to integrate in a different way with Space. So since we have no good answer to that, we decided to open up Space for everything. So everything you can do through the UI, everything that you can do in Space, in the browser, or in the apps that we have is available through an HTTP API as well. This does mean that there's a really large HTTP API surface. If you look at the API, you will see that pretty much everything is in the API, but that also means that there's close to, I think it's something like 170 endpoints nowadays in terms of HTTP API surface, and all of those endpoints can have sub endpoints and so on. So it's really a lot that is there. If you want to start integrating with it, we have an HTTP API playground that you can use to start exploring space and see whatever is in there. So let's maybe have a quick look at the API playground that is there so you can see how you can start working with it. So every user in space can start using the HTTP API playgrounds. And you will see, like I mentioned earlier, that pretty much everything you can do in space is part of the API and everything is in there. And for example, if I wanted to send or list all chat channels that are available, I can select this operation. I can do a query. Maybe I want to search for all the channels that are related to software development and then execute this query. You will see the results coming in. Apparently, there's a software development chat channel that we can use, and you get this information back from the API. All of the parameters that you have here are generated and can be added to the endpoints that you see. So you see that whatever you type is being generated there, and you can actually start using it. And it's quite nice to explore what is in the API. One other thing that I want to talk about is that in the response data, there is one specific parameter that decides which data is being returned. So for every single chat channel, and maybe this is not the best example, so let's do something else. Let's get a profile, maybe. There is going to be a get all profiles. If we run this query by default, or if we access this HTTP endpoint by default, you will see that you get back a response with 40 entries on one page, and you will see all of the profiles that are in this space instance. By default, we return all of the data that is available at the first level or at the first meaningful level of data to return, but you can do some more interesting things. So for example, if you get all profiles, you could do something like, I want to get back the data with just the avatar, with just the name. And for name, I want to have the first name and the last name. And let's say we also want to retrieve birthdays and things like that. Maybe we also want to retrieve vacation periods, absences. Is this person available? Since when until which date are they taking vacation? You will see in the requests that this is adding parameters to this fields query parameter. And you will see that we are retrieving data with avatar, with name. For name, we get first name and last name. We get a birthday. We get absences. For every absence, we get the available since until. And we can execute this and really shape the data that you want to return in the API. This is really powerful because imagine you would retrieve or would want to retrieve all of the names of all profiles in space. If you have a large organization, you will get a lot of data if you use the defaults. But if you just select the name or the data shape that we have here, you would get back just that data and the response would be quicker, less data transfer, etc., etc. Now, all of this makes it quite interesting to build integrations with space because if you are using this HTTP API, you will have to know about this fields query parameter that you can provide and what this data shape response should be about. But let's talk about that in a minute. I just wanted to show you that there's the HTTP API playground and you can essentially try to play with it and see whatever comes back from space. By the way, if you're using one of our SDKs, the .NET one is not yet in there, but the Kotlin one is, you will also see the source code for that, but that's skipping ahead for this talk.
I have a quick question, if I may.
Yeah, absolutely.
I'm interested in how do you manage database querying using this approach, because probably you need to generate a lot of SQL queries or something. I'm not aware what you're using as a database, and it looks like a complicated task to be able to build or generate SQL effectively for this kind of API.
Yeah, so on the space side, this is very similar to how you would build a GraphQL kind of API, where we essentially parse the shape of the objects that you want to retrieve. And we know the shapes of all of the objects that are there, and we will not let you query everything recursively. So for example, if you get a profile and the manager and the manager of the manager and the manager of the manager of the manager and so on, we essentially have a limit there that limits the amount of recursion that you can have to, like you say, not explode our database to have a little bit of rate limiting and shaping on what you can actually do. But it works both ways. Yeah, go ahead if you want.
Yeah, but basically you needed to implement your own micro ORM or something to be able to generate all this SQL, right?
Sort of, yes. So Space itself as a product is built in Kotlin. And in Kotlin, there's a popular something like entity framework in .NET. It's called Exposed, which is an ORM that you can use and that has support for doing some of these things where you shape the data that you want to retrieve and it then converts everything into SQL. It has those limitations or those limits that you can put on it depending on what you want to return there.
Cool. Thank you.
You're welcome. All right, so that was the internal side of Space. Now, if you're an API consumer, you will be working with this fields query parameter and you will be shaping the objects that you want to retrieve. By default, we return everything that is meaningful for a top-level field, top-level object. So, for example, if you get a project, you will get the ID, you will get whether it's archived or not. If there's issue boards, you will get a description and so on, but you will not get all of the columns of an issue board, as an example. If you want to retrieve those, you will have to be specific and decide which data you want to retrieve. The moment you start to be specific, you have to essentially provide all of the fields that you want to retrieve. You can also put an asterisk if you want, if you still want that default behavior. But once you start building that fields query parameter, you will have to shape the data that you want to retrieve. So for example, to just get the ID, icon, and name, you can provide those fields. If you want to go wild and get all of the columns of all of the issue boards that are in the project, you can do something like the third query that you see here, where you get ID, name, boards with their ID and their info and their columns and so on. Now, if we want to expose this as a nice .NET SDK for .NET developers, there's a couple of hurdles that we had to think about to build an SDK. We wanted to make it possible for our users to use .NET to build applications and integrations with Space for whatever your team or your organization is doing. We wanted to have a ready-to-use SDK, essentially install a NuGet package, minimal configuration, provide the URL and an access token, and that's it. And for the rest of it, we wanted to make it very discoverable. If you want to get user profiles, it should be straightforward for you as a consumer of this SDK to get profile data, for example, from Space. Essentially, what we want to do is lead you as a developer building an integration on a short path to success. So we started thinking, do we build this API handcrafted? Well, the short answer there is no, it's not a good idea. We have over 150 API endpoints, and I think by the time we will release next week, we'll have something like 170 or 180. There's over 700 DTOs in there, so over 700 object types that we would have to handcraft. That's just a bad idea. And since Space has been in an EAP and later on a beta during the rest of this year, we had some churn. Object types were changing. Sometimes endpoints would disappear or be merged into something else. So it was impossible to handcraft this because it would just be a ridiculous amount of work. And you can probably see that this is not the way to go. Now, we are also exposing the API as an open API specification. So we have a Swagger document that you can use to generate, based on that document, anything in as a .NET client, for example. So if you open it in any Swagger editor, you will see that all of the endpoints are in there. This is actually an older screenshot, but I think you can, those 170 endpoints are in that document on the right, so you can see the scroll bar probably. It's a really small one because there's lots of things in there. We tried doing this, and we quickly found out that OpenAPI does not do what we wanted to do. First of all, there were a couple of object types that we exposed through the API that by default are not being able to generate using NSWAG, for example. So we would have to write custom code generation for those specific types. Another thing that we found is that the code that was generated based on that OpenAPI specification was not very developer friendly. To get, for example, all of the absences for a user, we would generate something like this, where you have a request body of the type body. I have no idea what it is. That takes a member, a reason, description, location, and so on. So it's a data transfer object that I have no idea what it really means. Second of all, you will also see that as part of that request, there's a string fields I mentioned earlier that you can decide what the shape of your object should look like in the response. But if all we take in a .NET SDK is a string fields, then you as a developer, you as a user of this SDK would have to really know about how to form that query language on how to shape the data that you want to return from the API. So those two things are not really friendly for an end user of our SDK. So we started thinking, maybe we can expose our entire object model on the server. Because if we look at how Space is built, we have a server side that is built in Kotlin. Our DTOs and our query interfaces are all shared with the front end, which is also written in Kotlin, but then transpiled to JavaScript and React. So why not expose that same object model as an API itself? Why not expose the shape of all of the enumerations that are there, expose all of the DTOs that we have, expose all of the resources that are there, similar to an open API or a Swagger document, but more rich in terms of type information. So I can actually show you in the HTTP API playground, if you have a Space instance and you search for HTTP, you can actually retrieve the HTTP API model that we have. So for example, if you want to get all of the resources that are in there, you can get all of the endpoints with their display name. You can get for every endpoint also the display name and maybe the path as well. And then once you execute that, you will see that you get back a lot of information. But still, we can give you all of the information about this API in a model through this exact same API. So we are exposing this, as you can see, and you can get all of that information from the API. And you can build, for example, enumerations. In the API, we have a model where we model an enumeration. An enumeration has an ID, has a potential deprecation message, has a name, and has a list of the potential values. Well, we can easily script this in .NET. We can easily deserialize this from the API model that we get from the server, and then write an enumeration code generator like this, where we have an enumeration visitor that visits all of the API enums that we have, use a string builder, and then start appending all of the values that we have. And if we would run this with that API enum definition that we created before, you will see that you get something like this, where the generated code is an actual enum that works in .NET as well. So this is very straightforward, and we decided, okay, maybe this is the way to go, because having that rich object model exposed through the HTTP API means that for Kotlin, for .NET, maybe later on for PHP or other languages, we can easily generate the interfaces and all of the classes to interact with Space there, right? DTOs are also there. So we have an API DTO. So for every data transfer object that we have in the API, you'll see that, again, we have an ID. There's a potential deprecation message. There's a name in there. There's a list of fields for that DTO. So all of the type information is really exposed in the HTTP API. And we can use this, again, to generate code in C#. Endpoints are slightly more complicated. Endpoints are all of the URLs that are available in Space, and you will see that there's many of them. Endpoints can have child endpoints or child resources. Resources can have child resources of their own. So it's a big data model, and I decided to not put the source code on here, but just a class diagram of what the endpoints model looks like in Space. But again, for everything that is in the API, for everything that you can do with Space, you get back type information. So it's almost like if you would write pure C#, you get back type information saying this is a type, this is the name of the type, this type has certain properties, those properties have different types as well, and so on. So all of that is exposed in the API. Let's maybe have a look at some of that code generation so you can visualize what I just talked about. So again, in the API playground, you can get back, for example, all of the enums in there. That's the simplest type that we have in the API. For every enum, we can get the ID, name, and values. And if we execute this request, you will see that in the response, you get back things like, for example, an absence list mode where that is the name of the enum, and there's 3 different values for that enumeration. You will see that there's an access type. There's 3 different types for that access type as well. all string values. I know somewhere in there is a class or an enum called weekday, where for weekday or enumeration there, you will see all of the values being Sunday, Monday, Tuesday, and so on. So all of that information is exposed through this model. In our code generation that we wrote, we are doing something similar. We are using this HTTP API model endpoints to get all of the DTOs, all of the enumerations with their default values, all of the resources and their nested resources, and some other stuff. Once we have that, we parse it into an API model, and that API model has, just like in the web interface that you just saw, has DTOs, has enumerations, has URL parameters, resources, menu IDs, etc. For every enumeration, we have something similar like you just saw in the web interface. We have properties for ID, for name, and a list of all of the values that are available. So all of that is just a one-to-one mapping between our code generator and the response from the actual API there. Having all of this information means that now all of a sudden in our code generator, at some point, we can generate files. Our generate files calls into a C# API model enum generator, long class name, I know. But what we do in there is essentially for every API enum object from the API that we got from Space itself, we generate a C# class name from that definition. We append the deprecation if needed, and from then on, we just start generating a class to generate this enumeration using a string builder that has all of the values, and for every single value, we add a static read-only with that specific value for that enumeration. And as a result, if we run all of this, you will see that from that JSON-based HTTPI model, we get a generated class weekday that has all of those weekday names. And that's the wrong thing from my end. We have all of those weekday names there. You see the values are passed in, and all of this is generated based on that JSON that we just saw in the web interface. Right. Maxime, any questions so far?
Not yet. Let's continue.
Perfect, then we can continue. All right, so this was a very simple example, but just to give you an idea, we have this JSON model from the Space API. We take it into our C# code generator, and then out comes something like this, where you have an enumeration that gives you all of the values for that weekday enum that the API expects. Cool. Now you may have noticed that we were using string builder to generate that enumeration. We've actually been, if you're not familiar with all of the different types of code generation in .NET, there's a really good book about it, Metaprogramming in .NET. And essentially it gives you a few ways to generate code in C# or in .NET. You can do intermediate language-based code generation using reflection.emit, for example. That is possible, but for our use case, it seemed way too complex to generate just some DTOs and enumerations. You can do something model-based using CodeDOM, which is an older approach to doing things. You can use expression trees or Roslyn syntax generation to build the entire model of the code that you want to generate and then generate it from that model. But also that felt a little bit too complex for our use case. You could do templates using T4. You could do something like Razor-based code generation, essentially write some templates and write for eaches over all of the data that you have in there. But essentially, at some point, strings will have to be written and code will have to be written using just plain old strings and string builders. So we decided, okay, maybe string builder is the way to go for this. Actually, here is an example. IL was too complex for us, or too complex for this use case. The model-based and template-based approach is less readable. And there's two examples on this slide where you see the first one just uses a string builder and appends a line that generates a public property. I think that is very readable. The second code example that you see on this slide is a Roslyn-based approach. And I think generating a property using this Roslyn-based approach is perfectly fine. But to be honest, it's way more complex to read what you're actually generating in terms of codes. If in our code generation now using these strings, we look at whatever is there, you will be able to see pretty much where that specific part of the code is generated because it looks just like a string in there. To give you some background for our Kotlin-based SDK, not this .NET one, for the Kotlin-based SDK, we use something called Kotlin Poets, which is similar to how the model-based or the Roslyn-based approach works. In Kotlin, it felt like a more natural fit, but for .NET, the string-based approach seems the way to go. All right. Maybe you have also seen in our code generation that we were using extension methods. If not, there were a lot of places where we needed similar things, generating a C# class name or a variable name from a string that came from the JSON API model. Well, we decided to not build separate factories for this, to not build separate whatever for it. We decided extension methods are a good way to do this because for every single thing, like for example, generating a class name, we can simply call .toC# class name. So in this case, you see that we have an extension method on API DTO, where you can generate a class name for that DTO, but we can generate the same model or the same method name for generating enums. Let me give you a quick example there as well. So in our code generator, you will see at some points that we are doing this toC# class name. This one works on top of API enum, but you will find in the code base that there's also going to be toC# class names for other types of objects. So if you look at, for example, the extension methods for DTOs that we have the same method name, but this time it uses API DTO as the inputs. So for us to write this code generator, all we had to do was think about the fact that we have something, could be an enum, could be a resource URL, could be whatever. And there's going to be a method called .toC# class name that generates a class name based on whatever we have at hand. And there's actually quite a lot of extension methods in there for generating documentation and a lot of other things. Cool. Something else that we ran into, system.text.json. When .NET 3 came about, system.text.json was the new .NET JSON serializer and deserializer. And we thought, okay, if we think about developer experience, the last thing we want to do is that when you install this JetBrains Space SDK client, the last thing we wanted to have you to do is install newtonstuff.json, because that's an additional dependency. Maybe you are already using that library, but a different version. We wanted to use whatever is in the box with .NET, and in this case, it is system.text.json. Just making it easy for you as a developer using our stuff, that you don't need those extra dependencies. Unfortunately, system.text.json is not a 100% replacement for newtonstuff.json. There's a number of things that we found missing in that library. I think with the latest .NET 5, there's still 3 things that we are currently missing. One is polymorphic serialization and deserialization. The other one is to deserialize JSON nulls as literals into non-nullable value types. Good thing is that we can build our own custom JSON converters to more or less build something that works with this. And we have quite a few of those in our code generator as well, but also in the SDK that you are going to use to interact with Space. So let's look at a couple of examples there as well. I'll start with a really, really easy one. We have seen those enumerations being generated. So for example, this weekday is a sealed class that has several properties, Sunday, Monday, Tuesday, Wednesday, etc., with the values that the API expects. You will see that we have an enumeration converter slapped on top of it. So if you look in the enumeration converter, you will see that we are doing some manual conversion to get a string from the API that is in Space and convert it into the object that we have in the generated codes that we have. So what we do is when reading something that is an enumeration, we look whether it's a string coming back from Space. And if that's the case, we parse it using our custom enumeration type .fromValue and converts that to an enumeration. The other way around as well, if you're writing to our API, you are using that enumeration, and we simply write the string value for the value of that enumeration. So this is a very simple one, but it allows us to generate or at least work with the strings that Space API returns and have something more meaningful like this weekday enumeration in the code that you are using in your integration with Space. A more interesting one is our class name DTO type converter. That's the one, yep. This is one that does polymorphism. Before we dive into the code of this one, I'm going to quickly show you something in the model. Actually, in retrieving the API model, there is also already something that may be of interest. We have DTO types that are returned from the API, and a DTO can have multiple fields. Every field has a field definition, and that field definition specifies which type that field is going to be. Now, this API model that Space exposes has different types in its type system. The type of a field can be an array, can be a DTO, can be an enumeration, can be a map, an object, a ref, a URL parem, etc. So you can see those on screen here. And to distinguish those different types that can be returned from the API model, what is being returned is a property called class name. And based on that class name, we can instantiate the correct object type in the consuming API in .NET. Now, unfortunately, by default, system.text.json does not support this type of deserialization and serialization. So whenever we encounter something that is an HA type, in this case, we will have to look at the property name here to find the correct .NET type to represent this specific one in code. So we had to write our own class name DTO type converter to do this. And what we're doing there is a couple of things. So first of all, we are reading the JSON that comes over the wire. Since system.text.json is all struct-based and reference type-based, value type-based, we can make a copy of our reader by simply assigning it to a new variable. Using that copy of our reader, we can parse the entire value of whatever we are getting in. If we find that class name property there, we have an idea what type of object that should be returned here. So if that is the case, we can then start deserializing our objects in the end with that copy of our current JSON reader. So this is one approach to use some additional metadata, but still return the correct type in your API. To give you an example, I think there's actually something in the README where a code review can have contributions from an actual person or from an automated system. Those are two different .NET types in the API that you will be using when you're interacting with Space. Well, that is passing through this JSON converter to make sure that you can actually use the correct type in your .NET code as well. By the way, this one, if you Google my name, find my blog, I think I wrote a more detailed explanation about this specific JSON converter. There's a couple of other interesting things that are in there, like type caching and making sure that we're not deserializing into types that should not be available. But I encourage you to look that up and read a little bit more about it if that's of interest to you. Right. Let's talk about some other stuff. Actually, the link was there, so you can find it on my blog. It was a blog post in January this year, so you'll find it there somewhere. Cool. Since we are generating codes, we also wanted to generate code that is easy to use for you when you are building an interaction with Space. So we try to focus on developer experience a lot. The ideal getting started for integrating with Space for us would be that you register an application in your Space organization, you install our NuGet package, you create a connection, and then you do whatever you want with it. So first of all, we wanted to make it easy for you to find out what you can work with. So if you look at the HTTP playground that is available in the web UI, you will see that there's those top level things. In the .NET SDK, we generate those top level elements as something client. So if you want to work with the team directory, you will find a team directory client in Space. Then all of the sub-resources there, or all of the properties, like birthday events, for example, are a property on that theme directory client. So if you want to get birthday events, you look at the API playground, you will see that it's under theme directory, calendar events, birthday events. Well, in the .NET SDK, you will see that there's a theme directory client that has calendar events, that has birthday events, and then has all of the methods that are available. So when looking at just the HTTP API playground, it should be easy for you to figure out how the .NET SDK works as well. Second, remember that fields objects, we still wanted to give you the opportunity to shape the responses that you are retrieving from space. So we started thinking about how it would be possible to expose this fields query parameter in a .NET SDK, because there obviously we want everything to be strongly typed, but still it should be possible for you to use it and shape the response types that you want to retrieve there. So what we did was do something like this, where in the .NET code, by default, we return all of the top-level fields from the API, just like the actual API will return to you. If you want to get nested fields, if you want to get, for example, managers, we have all of these partial methods that you can call, and they're all with and then the property name to get, for example, managers with their ID, with their username, with their name, first name, etc. I know this is kind of verbose. You don't have to use it if you only use the top-level data, but if you want to get profiles and their managers in one call, this is the way to go forward there. But again, it looks very similar to what you see in the HTTP API playgrounds. Right, so let's look at that developer experience there. When you are consuming our generated codes, what we want you to be able to do is to start working with it immediately. So you will see in this example codes that we have a main method where we create a connection, and from then on, you can simply start working with it. If you look at the HTTP API playground, you'll see that there's a theme directory client or a theme directory. Well, you can create a client using that connection and then start working with it. If you start typing and do a theme directory client dots, you will see all of the properties that expose different clients. So for example, if I want to get all of the languages that are being spoken in the company, we can get languages, dots, and then you see all of the other API endpoints that are available. So it should be easy for you to discover those things. Same thing with getting those properties. All of these partial methods are available. And if you start typing .width, by using clever code completion and some namespace juggling, we make it easy for you to figure out which properties are available, for example, on a user profile. So you will see that you can get emails or birthday or avatar or the about message and things like that. So all of those are generated there as well. For everything that is in there, there's also a couple of other things that we wanted to do. And we wanted to make it easy for you to not forget to add one of these things, for example. So in our code generator, what we do is we have something that for every single object, so if you look at the first name, for example, all of this code is generated. It's not really a string property. It is something that is backed by a property value object that is a string. What we do when deserializing whatever comes back from the Space API is we either set the value for that property value or we don't. But if we don't, this property value object will, when accessed and getting the value, will throw a property not requested exception by default. The interesting thing there is that if you write something like this, where from the theme directory client you get the profiles and you get all of the profiles with just their ID, if you then access the name property or the first name property of that name, you will get an exception telling you that you should add a .with name to be able to access this property. So let's maybe run this one and put a breakpoint there, and you will see that if we run this one, you'll see that at some point we will get this property not requested exception because we are accessing the name and the first name, but we did not retrieve it from the API. So let's wait for this one to run, and then you should be able to see that one. All right, there we go. It's now running, or it should be running. There we go. We get back some profile data, which is a previous call, but once we start calling this one, you will see that all of a sudden an exception will pop up. That's some data, there's our exception. So what the API client tells us is that we have an exception, and that exception is that we are retrieving a member profile, and we should be using with name to include it there in our source codes. By the way, this can be disabled if you don't want it, but it's pretty handy to figure out what you are doing wrong, maybe when using the SDK. Now, I did not yet mention this, but the SDK is also on GitHub if you want to look through the source codes. And a lot of those developer experience flags that the code generator is using are exposed in a feature flags object. For example, if you don't want those backing fields giving you those exceptions, you could run the code generator with false there. And then we could run code generation again against our demo instance. And then you will see in the diff that all of a sudden our code generator is no longer returning that specific behavior with those property values that are there. So this should come back at some point. It's going to be a large change because lots of files will have changed because we changed that flag. But in the end, you will see that for every DTO that we have, we are all of a sudden no longer, sorry, I should go there, under generated. You will see that we are no longer generating those property values, but instead we're just returning traditional properties that can be null in this case. So you won't get that developer experience from this code generator. There's a couple of other things like this in there as well, but let's highlight maybe a couple of the other developer experience things that we have in there. Batches. A lot of the data that we expose in space in the API is going to be batched. Typically, this is going to be something that retrieves all of the to-do items, all of the issues, all of the projects, all of the chat channels, and so on. All of that data is going to be exposed in batches because we don't want you to retrieve 20,000 instances, for example, in one go. What we want to do, what we want you to do is essentially get just the data that you need, and you can do that using a batch. A batch is essentially a page of data that is being returned. Now, we found when first building our Space SDK for .NET that having code like this, where you have a batch where you get all to-do items, and then having to write a do while where you get the next page and the next page and the next page is quite cumbersome. So we decided to write something like this, an iasync enumerable helper that we generate that gives you a for each over all of the to-do items as an async enumerable, and that will in the background do all of the batching and paging for you. So you don't have to care about that too much. Still, if you only need the first 5 items, this will only probably get the first page. If you need all of the to-do items, this iasync enumerable will get all of the pages that are there. One interesting side effect there is that we found that when you have this, it's very easy to start doing something like getAllProjects.count. And that will, because it's an iasync enumerable, get all of the pages that are there with all the data. And that's a really expensive call to get all of the data from the API. So if you just want to have a count of all of the data that is there, we suggest you use the old getAllToDoItems async with just that total count property that you see on there as well. Right, quick demo there too. If you look at the program that we have, close all of the other tabs for a moment. You will see that when we get all profiles, where is that one? We are doing that as an iasync enumerable. In the background, what our code generator is doing is generating methods like this that call into a batch enumerator that then calls into the actual methods that we get from the Space API. But still, it makes it easier for you as a developer to have a good developer experience of using this code that we have in the SDK. In terms of code generation, this again is hidden behind a feature flag. And if we search for usages of that feature flag, you will find that, where is it? It's not in there. It should be enabled, and you will find it in the codes, and you can see where it is generated, and yeah, that it's actually useful for you as a consumer of this API. Just a quick example of one of those ways to make it easier to consume this thing. Another thing that we added, if you think back to our Open API slides that we had earlier in this presentation, we found that it's not very friendly to have something that takes some objects. We decided to flatten all of the request bodies. So if you get, for example, all of the absences that are in the Space API, you will see that what our code generator does is, in the background, it still creates a request objects, but it exposes every single parameter or every single property of that request object as a parameter. Let's maybe have a quick look at that one as well in codes, so you can see what it does. If you get, for example, all of the absences, or just one absence, you will see that this is a request that takes, where's my get all absences? Yeah, maybe updates. This is a request that takes an absences for ID patch request as the request body that has a member, a reason, a description, location, etc. If you are going to use this method, we want to expose just update absence async and provide you with those parameters directly without you having to create an absences for ID request there. So again, another step to make it easier for you to discover what you can do with the API there. What else is there? Factory methods. We also found out by essentially dogfooding this SDK and building examples and building integrations with Space, that's to create, for example, a chat message, and let's maybe put up the slides, that it could be very easy if we generated some factories for you. As a consumer of this Space SDK, which option would you prefer? Would you prefer to await a chat client that send message async and then create a new message recipient channel and then a new chat channel from name? We did not think so, so we decided to generate factory methods that give you a message recipient.channel that creates that message recipient channel in the background, and to make it easier for you to discover which parameters are available. And I think the second one is much more concise and makes it much easier to start consuming this specific API. One last one that we unfortunately are not able to generate for you is this one, default values. To give you an idea, and let's maybe toggle that feature flag and generate the code to see what it brings. I'm gonna undo this one and then change this one as well. It won't compile, but we still decided to add it as a feature flag to generate the code that is available. The Space API has a lot of optional parameters. And those optional parameters on the HTTP API playground, you will see that most of them are have sensible defaults. So don't have a good example at hand, but typically when you create an absence and you want it to be a vacation, we think vacation is probably going to be the absence that you request most of the time. So that's going to be one of the defaults that we have there. Well, we decided when generating code for you that it would be nice if .NET supported defaults for reference types. It would be nice to do something like this, where, let's look at the example here, where for those default values, we can generate something like this, where your defaults can be nullable and where we return a proper object. This is not the best example. Let's maybe look at another one, this one. Is this one more interesting? Nope, that's not more interesting. It's always hard because our API is still changing. It should be more stable next week. But yeah, let's maybe take these absences as an example. This should have something. It doesn't. Damn it. I'll show it in the slides. So essentially what we want ideally in .NET is that there are default values for reference types. So we can make it possible to have something like this absence list modes to be defaulted to absence list modes.all. So that when you invoke code completion, you get that out of the box and you can see what that default is. Again, developer experience, we want you to be able to see what is going on. We are currently using a workaround in the generated code and are actually just allowing you to pass in a null value. If we see that you pass in a null value and it's actually nullable, we will replace it with the default value that is there. But still, that's not very developer friendly. You don't see what the default is. You will have to consult the HTTP API playground to figure out what the default is. So we are considering to add some XML documentation to make it more clear what the default is. But yeah, it looks like there's no good option right now. Maybe in C# 10 or 11 or 12, we will see default values for reference types. Would be nice. Cool. Some other things that we have in terms of code generation. We wanted to focus on developer experience, like I mentioned earlier. And some of the things that we have is some shortcuts to make it easy for you to consume space in your own application. So for example, if you want to write a ASP.NET Core web application and you want to authenticate through space, well, we are generating some code that makes it possible for you to just type .add space and you get space authentication in your application. We have a .add space token management as well to make it easy for you to work with all of the different APIs as the user who is currently logged in. So all of that is there as well. Before I jump to the conclusion, there's one additional thing that I want to show you, because I think we're almost running out of time for the actual session. I mentioned that the code is on GitHub, and all of the code for our code generator is there as well. There is actually a branch that is called mb.net source gen. I've been playing with using .NET 5 source generators to generate this entire API source codes, and it's actually working. So if you clone this branch and run it against your space instance or use an exported JSON file to generate it, it will actually work. But there's one downside that I so far found to using this approach, and that is that it's almost impossible to generate code whenever you want it by just invoking generate code commands. .NET 5 source generators are only invoked when you change something in existing codes. So the workaround to trigger this space client source generator in .NET 5 would be to make a change somewhere else in the project, which would then invoke code generation. But that's not really handy to do and not ideal. But I think if it's possible to invoke source generators at a later point or at a custom point where you want to run it, would be much nicer to have this approach, because then we could ship this as a NuGet package of itself. We would no longer have to ship you binaries of everything that we generate. We could just ship you a space client source generator, and you would always have a space SDK that targets your specific version or the version of your space instance. But that's maybe for later, maybe not. We'll see how .NET evolves. Right, in conclusion, I think we can say JetBrains Space is an integrated team environment. There's lots of things in there that are integrated by default, so you can see absences, things like that. We have lots of integrations out of the box, but of course we cannot cover every single scenario that you may have in your organization, which is why we're exposing everything as an HTTP API endpoint. We are also shipping a .NET SDK for that API to make it easier for you as a .NET developer to build a successful integration with Space, and so you can build it without having to read too much documentation to discover whatever is in there. We're heavy users of code generation. We're not using anything fancy apart from string builders in there. And everything has the main goal of focusing on developer experience to make it easier for you as a consumer of this SDK to get started with it. And again, if you want to look through the sources, if you want to see how code is generated, everything is on GitHub if you want to look into it. With that, I think we have some time for questions.
Yeah, don't see any questions on chat right now, but I have a list of my own. So it's really interesting to see how people, different people working with different kind of method programming or code generation, they all kind of go with the same pattern. And when I see something, when I see pieces of code really similar to what you just have shown, it always means that some kind of code generation is involved. I don't know what it is, I mean, the actual implementation, but the structure of the code clearly says to me that it's a code generator. And personally, I like the approach with String Builder, especially looking at the example with Roslyn and with a String Builder. The later one looks much clearer to me. So the first question, I have a completely random idea. So this code generation is limited to Space API as of now, correct?
Yeah, correct. Well, in theory, if you would generate your own HTTP API model in the same structure that we have, then it should work for pretty much anything. But
yeah, exactly. So we sometimes generate client code based on Swagger, like DTO, based on DTO structure. And personally, because I don't like to work with JavaScript too much, so it's a good idea to take DTOs from the OpenAPI definition and to generate some code which later can be edited by developers. So combining this approach with yours, we can end up having a system where non-technical person can define their own API by clicking on what they would like to expose, then generate the API, and the next step, based on the selected DTOs, they can generate the UI. So basically, we can build a lot of CRUD-like interfaces without writing a single line of code. Am I correct here? Am I correct here? Apart from that, there has to be a lot to do.
Yeah, it's a big to-do, but I like the idea. And I think actually OpenAPI is kind of geared towards doing something like that, where you expose what you want. And I think something like NSWAG Studio for .NET, for example, gives you the ability to at least change a couple of the code generation options and then generate it from there. It proved too limited for us, but like you say, in theory, you could do something like this where non-developers can build SDKs for developers like this.
Yeah, and as far as I understood, you do not expect developers to modify the generated code, right?
No, but we do open source it, and the idea is if .NET 5 source generators would work for this, the idea would be that we only ship you the generator as some sort of an analyzer, and that based on the specific space version that you are using, you essentially generate your own client at that point.
Okay, nice to know. And I have a specific question more related to the product itself than the code generation. So JetBrains is famous for having TeamCity for continuous integration, UTrack for project management, and IDEs for developers. So right now, Space looks like an alternative to rule them all, correct? It's like integrated team environment. So can you share the plans how those products will coexist? I mean, they are competitors in a way, you know.
True. Yeah, I think it's convenience over power is going to be the answer there. So yes, Space has issue tracking. It has automation where you can do continuous integration, where you can do deployments and so on. But depending on your needs, you will either be perfectly happy with whatever comes in the box that is Space, or you may need something else. So UTrack and TeamCity are definitely not going away. On the contrary, they are very actively developed. And what we want to do on our roadmap for Space is also integrate those into Space, so that when the issue tracker that is in Space is not sufficient for you, you will have an out-of-the-box integration with maybe a UTrack instance. Same thing for automation. If you require all of the features that are in TeamCity to set up complex builds and pipelines and so on, it should be easy to combine that one with space. So it's really either you get this, everything is in one box and you get basic issue tracking. You can still use the API to do some automation on top of that. You get that, or you get a really more powerful product that has all of those things by default.
Yeah, and I think that's the point where, we run out of time, or? No, we have. Okay.
Nope.
So, good. I mean, that's the point where things might be more complicated, because as of now, we are happy with UTrack. Apart from that, there is no convenient way to track absence and vacations, holidays, things like that. So what we would like to have as a team environment to work with those and keep UTrack as a project management system. And there should be bi-directional integration between those. And you expose the API, but that's a part of the story. You also need a background service or something which runs against two databases and manage this eventual consistent world somehow. Do you have any ideas on how you work with this, because you will have to generate a lot of integration code, which is not only API but also related to the background services.
That is something. So for having those things out of the box, that is something that we're currently thinking about, and should show up at some points. If you currently have such an integration that you require, there's a couple of things that you can do. So in the automation in space, it's essentially a build pipeline where you can configure your entire builds, but you also have access to all of the APIs that are available in space. So you mentioned you need maybe a background service that has to run. That could be space automation, where inside of your automation script, you can script something that, for example, sends a chat message notification when something happens in UTrack or something like that. So essentially, having automation means that you also have hosting for that type of workflows inside of space.
So I can run my .NET code inside of space as well, and keep this synchronization logic inside of this pipeline.
Yes and no. So the pipelines are Kotlin based. So by default, it's all Kotlin, and you can do that. But again, I would say go to my blog. I actually wrote a blog post yesterday about synchronizing my personal Office 365 calendar with what is in space. And I am running it as part of space automation, even though it's .NET codes. So if you're interested in that, the idea is you essentially have a .NET project that uses the space API that uses whatever other integration that you have. And when you run it, things happen. In space automation, what you can do is build that application and then run that application as part of the same builds.
I will definitely check it. Nice to know. So let me check. So Ruslan, have you wanted to ask something?
Yep. I'm not sure. I'm actually good enough to ask more questions. I guess I just wanted maybe to ask Maarten if he can provide us any insights before the public, before space goes to public, so we could get something from first hands before everybody else knows about space.
The release is going to be next week, but that I think we announced that on Twitter.
Yeah, you did.
It's really hard to tell because everything essentially is already in the current beta that is live. The only thing that will change is that we call it stable, and things like the API, for example, will be a little bit more stable than they have been in the past couple of months. But other than that, next week you can subscribe and try it out and see what your team can do with it.
Yeah, that's great. But By the way, how do you usually understand that it's stable enough to put it in production, to put it public for huge projects like space? As far as I understand, like there is some kind of integration, automation, automated testing, manual testing, and so on. So, or you're just looking that your early adopters are saying that it works smoothly, and you're like, oh, well, now we can go public. Nice.
It's a little bit of that and a little bit of some other things. So it's a complex equation between what are the features that we want to ship, what are the features that most of our users will want to have, and what would be a good date to essentially ship it. So the way this release went, for example, is that we decided December would be nice to ship, even though I think somewhere in March we decided that it would be September, but we postponed until December, just because we wanted to have some base functionality out of the box without stable users having to wait for it.
Yeah, but like this autumn is like autumn of postpones, so everything was postponed. Like iPhone was postponed, Cyberpunk was postponed, like space is now postponed, so I guess that's totally okay. And now I can actually say thank you, Maarten, thank you, Maxim, and ask you to move to discussion zone. And if you are watching us, the discussion zone link is in Telegram chat if you are there, or it's right under the player under Maarten. Thank you guys, and I will just move on. Bye.
Thank you.
All right. Thank you.